Dear students, in today's lecture, we will discuss about steam condensers and their types. So, what is a steam condenser? First, we have to understand that. So, a steam condenser, in its simplest form, is a heat transfer device. It transfers heat and which reduces a thermodynamic fluid from its vapor phase to its liquid phase. So very simply we can say a steam condenser is a device which changes the phase of the steam into water. So there is the phase change from the gaseous phase to liquid phase. Because its name is steam condenser, so it is condensing the steam. Steam will be changing from its gaseous phase to liquid phase, that is water. The main use of a condenser is to receive exhausted steam from a steam engine or a turbine. What is the main use of the steam condenser is it will take the steam from a steam engine or from a steam turbine, and by taking its heat, it will condense it. What is the benefit of that? So its benefit is, we can say, the energy which could be exhausted to the atmosphere is utilized, and the engine or turbine exhaust conditions are stable and controllable. So here we can say that the steam which is going to be exhausted, if it is having some amount of heat, if that heat is being taken, then we are saving that amount of energy, and we reconvert the steam into water, and the water will, with the help of the that is hot bell, it will again pass to the boiler. So the steam condenser generally condenses the steam to a pressure significantly below atmospheric pressure. Means the condensation of the steam in the condenser will occur slightly lower the atmospheric pressure, because if the condenser is working at the vacuum pressure that is below the atmospheric pressure, the work obtained from the steam turbine will be more. This allows the turbine or engine to do more work. The condenser also converts the discharge steam back to feed water, that we have already discussed, that the steam which is going to be condensed in the condenser will be converted to the water, and that water will be sent back to the boiler, which is returned to the steam generator or the boiler. So, because the boiler is generating the steam, steam goes to the steam turbine where the work is produced by the steam. Then the steam then goes to the condenser where the heat is taken from the steam, and the steam is converted to the water. And with the help of the hot bell, again, the feed pump takes the water from the hot well and resupply it to the boiler. So in this way, a cycle is completed, but the phase change will occur. In the steam condenser, the phase change occur from the gaseous phase to liquid phase. But in case of the boiler, the phase change occur from the liquid phase to the gaseous phase. It means the water is converted to the vapor in the boiler, and steam is converted to the water in the steam condenser. In the condenser, the latent heat of condensation is conducted to the cooling medium flowing through the cooling tube. Because either steam condenser or the boiler, in both the cases, phase change will occur. The phase change will occur at the constant temperature, that is the saturation temperature of the substance. But it is also a heat exchanger. There are different types of heat exchangers. We will cover here few ones. Now see, you can see this figure of the one condenser. So here you will see that this figure indicates at the top side you can see the steam is coming from this side. You can see here the steam is coming from this side, because this is the exhausted steam. This steam is coming from the turbine. It is coming from the turbine. or we can also call it as steam turbine. So steam is coming from the steam turbine, and the water here, the water is coming from this cooling point. There is a storage of the water which is having the cold water, and this cold water is coming through some pipe and flowing this passage. Now this water is reaching here. So you can see there are some nozzles. You can see here four nozzles are being shown here. Steam, which is the hot steam, but the exhaust steam coming from the turbine, and water is coming from the cooling point. What will happen here? The exhaust steam here will give or reject its heat to this water, or we can say the water will take heat. So when the water will take heat from the exhaust steam, it will change its phase, means that will convert the steam into the water. Some baffle plates are also here so that they can change their direction for the flow of this steam. So that maximum amount of the energy, heat energy can be taken from the steam to convert into water. We are also using here a air pump, because when the steam is coming, there are chances the air can also enter this system. So a air pump is there so that it will draw or suck the air, so that air should not be mixed here. Then at this side, you can see this is called as a condensate. The water which has taken heat, it is in the liquid phase, and the exhaust steam which has been converted into the water is also the water. So these will mix together, and it is called as the condensate. This condensate here, with the help of the condensate extraction pump here, the condensate extraction pump will extract this water, and this will be then supplied to or stored in a reservoir which is called as the hot well. So hot well is the reservoir. Now from this hot well, with the help of the feed pump not shown here, we use a feed pump. So with the help of this feed pump, this water is resupplied to the boiler. This water is resupplied to the boiler, and the overflow of the water is goes to the cooling point, where the cooling point again supplies the water in this section, where it will take heat from the exhaust steam and convert it into the we can say water, fetching the water. Actually this is the function of the condenser. Here we are converting or changing the phase of the steam into the water, and how it is being circulated to the boiler. Now, there may be different types of condensers. So there is one more which is called as the condenser jet or mixing type of condenser is there. So here there is some figure you can see. So here also the process is approximately same. The water is coming here from this passage, again from the cooling point. Actually, it is a mixing type of condenser. So the water is coming here, and from the top side, you will see the dry pump. This dry pump is also there. Now here from the left hand side, you will see the injection water spray. Means here from this spray, we are injecting water. So water is coming from these sprays from the both the sides. Now, exhaust steam inlet. From this downside, you will see the exhaust steam will enter from this side. Means from the lower side or downside, the steam will enter, and from the top side through the sprays, water is coming. So water through the sprays is converted into the small particles, and the steam is reaching here. So when this steam will go up, because it is lighter and it is also slightly hot, so it will go upward and water will come downward. So there will be the mixing of these two fluids. Means the exhaust steam will mix with the cold water. So what will be the result? The water which is the cold water, it will take heat from the exhaust steam, and so this will convert the exhaust steam into the water. So here at this portion you will see this is actually condenser cell. The water is stored here. It is called as condensate. This water stored here is called as condensate. Condensate is this. Water is stored here. Now, now you will see here this is the setup of this same portion. So now this is the condensate. Here we are using a pump known as the condensate extraction pump. Condensate which is collected here, it is extracted with the help of feed pump and then it is stored here, which is called a reservoir known as the hot well. So in this hot well, the condensate or we can say the converted steam into water is stored here, and here we are using a pipe with the help of which it is supplied to the boiler again. We also use here one pump known as the feed pump and overflow pipe. It is the overflow pipe which takes some water and it goes to the cooling point. Some portion of water is stored in the cooling point, and with this from this cooling point the water is taken and that it goes to the condenser. There it will take heat from the exhaust steam to convert it into the water. So in simple, this is the process of converting water into steam, and this is the function of the condenser. But the condenser work at the lower pressure, that is called the vacuum pressure. Lower means it is less than the atmospheric pressure, because of which it increases the turbine work output. Thank you.